Hi everyone, welcome back. As was just introduced, this session is going to be in English. And different than before, we will have two presenters on stage here. And I'm very excited for this talk because we will be talking about high and really cool innovation. There will be two people presenting, as I just said, and the first person will be Joep Klein-Teeslink. He's a senior data scientist at Society. And he will present together with Babar Khan. He's a quality and test architect at Air France KLM. And just to tell you a little bit more about Joep, Joep's background is in software development. And Joep was one of the core developers for the AI agent of this VR training simulation at Air France KLM. He's very enthusiastic, I heard, but there will be only enthusiastic people on stage here for this presentation. And his passion is really, his passion is all about innovation, and he very much enjoys exploring state-of-the-art AI technology to bring value to Society and its clients, and then today, particularly KLM. Babar Khan has a track record of working for several corporations, always in the field of quality testing. He's been working with Air France KLM for over 15 years now. An innovator, a visionary, who's determined to improve quality standards. And some of his specialties are analyzing quality and test challenges, bringing strategies to life, and also coaching teams. Long introduction, but good to know. They're here together now. Please come on stage, Babar and Joep.
Okay. Good afternoon, everyone. So, 1 year ago, I started helping a team with improving their quality and test standards. This team was creating amazing virtual reality applications for Air France KLM. Since we were dealing with new technology, at one point we faced some quality and test-related challenges. So together with Society, we arranged some brainstorm sessions on how to tackle these challenges. So we brainstormed, and then eventually we found a solution. A solution completely out of the box and never tried before. A solution so amazing that we were like, we have to try this. Are you curious what that solution was? So, I'm Babar Khan, this is Joep Klein-Teeslink, and together I will take you on a journey of intelligent QE applied to virtual reality. So, it's already been said a lot of things. I can just say I had back then more hair than now. But I've been working in quality and testing for over 15 years. And I love basically investigating, exploring how to improve quality and testing with the use of new technology like artificial intelligence and for new technology, so like virtual reality. Joep, you want to add something?
So I've also already been introduced, very well introduction, thank you. I'm a reinforcement learning expert at Society, and I have a background in software development. I have dabbled a lot with automation of game software, so yeah, this was a great opportunity for me to combine my interests.
So, before we immerse ourselves in intelligent QE, let's have a look what virtual reality actually is. And there's a warning for viewers who have motion sickness, so some videos may be a bit difficult for you guys, but hang in there. So, virtual reality is about computer-powered three-dimensional environments that allow us to experience a reality which is different from our immediate one. So, with the use of computer technology, simulated environments are created. And unlike traditional user interfaces, the user is placed inside an experience. So instead of having a screen in front of you, you are basically part of the reality of the world and you're able to interact with 3D objects. So we're talking about images, we're talking about videos, we're talking about games, we're talking about software that offers a 180 to 360 degree field of view. And these realities don't have to be something completely out of this world. It can be something we already know, like a museum or an experience like swimming with dolphins. And I think you already guessed that you need some kind of headset to experience virtual reality. So let's have a look at an example of virtual reality. So this is a game, virtual reality. This is one of the most popular games in virtual reality. It's called Beat Saber. It's a VR rhythm game. So in this game, you have to slash the beats based on the rhythm, surrounded by a futuristic environment. So this example gives you a good image of how it would feel like, or how it is to play this game. There's a Parasoft Experience Center. If you would like to play this game, then today's your lucky day. You can play this game. So not now, of course, after this presentation, but so over the past couple of years, KLM has been working on some trainings, some virtual reality trainings. So allow me to show you some of these trainings. So this is the fire extinguishing training, or the fire safety training, sorry. In this training, the trainee can basically learn the firefighting actions. And the goal of this training is to basically experience the consequences with incorrect actions. And the trainer has a control panel, and the trainee is able to interact with passengers. But this is the fire safety training. This is a post-evacuation training. So in this training, you are on a raft after an emergency landing on water, and you have to follow all the procedures to disconnect the raft from the aircraft. And you have to make sure that the emergency kit from the water is placed back in the raft. And eventually, you will hear a helicopter, and then you have to shoot the flare from the emergency kit in the sky. This is the Jetway bridge training. So in this training, you have to connect the Jetway bridge to an aircraft. And this simulation is a one-on-one realistic build of the actual Jetway bridge process, with all the procedures and with all the handlings. This is the pushback training. In this training, you are in a pushback truck and at Schiphol Airport on a platform, which is also a one-on-one realistic build. And you have to push back an aircraft. And the trainer is able to modify some things. So he or she can change the weather, can make sure if it's dark or night. And the trainer can even select the gate, because from some gates it's more difficult to push back an aircraft than another one. And the last one I want to show you guys is the cockpit training. This is the cockpit training of the Embraer 195-E2. And in this cockpit training, the pilots, they can basically train the ground procedures. And this is very handy, because before they enter any aircraft or a simulator, they can already get familiarized with the ground procedures and practice. So the time in a flight simulator or aircraft is more effective. So how do we test virtual reality, and what makes it different from conventional testing? Before we talk about the differences, let's agree on the similarities. Because basically, everything we know about software testing is applicable for both fields, on both fields. So, for both fields, like if you look, so virtual reality testing inherits basically all the aspects of software testing in general. So then, what makes virtual reality unique? So, during conventional testing, we have to deal with applications which are two-dimensional, and most of the time you have a graphical user interface or a command line interface. But when we during virtual reality testing, we are dealing with applications which are three-dimensional or sometimes even four-dimensional. And next to a graphical user interface and a command line interface, you also have to deal with a natural user interface or an organic user interface. So a natural user interface is an interface which speaks for itself. So you don't need a lot of instructions. So let's say an application where you have to paint. It speaks for itself. You have to pick up the brush and you have to start painting. So that's a natural user interface. Organic user interface is an interface which is seamless, almost seamless with our reality. So it changes with you, basically. Based on your actions, it adapts based on your actions and what you do. So the biggest difference between virtual reality testing and conventional testing is that we're dealing with a different kind of user interface. A user interface where usability is super important. So let's suppose if I have a website and the usability is not one-on-one, I might get away with it. But if you have a virtual reality application and the usability is not one-on-one, so let's take one of the trainings you just saw, then I can't get away with it. I basically will miss the goal of that application. So this basically means that additional quality characteristics are applicable or should be tested during VR testing. Quality characteristics which are less applicable for conventional testing. So this is the ISO, the quality model ISO 25010. And this the product model is used to determine which quality characteristics are applicable when you're testing a particular product or application. And when it comes to virtual reality, this product quality model can be expanded. So, which quality characteristics? Well, I'll just name them first, like realism, touch, physics, audio, balance, immersion, haptics. So let's zoom in some of these. So realism, like let's say an object or a person in virtual reality should be represented as such that it's accurate and it's true to life. When you touch something, it should feel like you're touching the real thing. It should feel real. Physics, like the law of gravity or how the objects move in the environment, should be realistic. Audio, the sound of things around you or objects should also be realistic. I will jump to haptics. Haptics is basically like the extra sensation you get when you feel something. So let's say when you're gaming and the ground is shaking, then your joystick starts shaking. So those are haptics to emphasize the immersion. And all these 5 points, realism, touch, physics, audio, haptics, together they basically create the balance and the immersion. So these are some of the most important quality characteristics applicable for virtual reality. So how do we test? What was our approach? How did we test? How did we basically improve our testing process for virtual reality? So the first thing we did is we changed or switched our ice cream cone into a pyramid. Why did we do that? I always say you have to walk first before you can run. So we started with the basics. So after turning the ice cream cone into a pyramid, we basically looked at the individual levels and tried and focused on improving the individual levels. I'll just go quickly through the different levels. So we first started, of course, with the unit test level. The unit test level is basically the fundament of the pyramid, and testing at the unit test level is cheap and it's fast. So what we did is we focused on these 3 things, these 3 test types, to improving them and sometimes even implementing them. So static testing, for the people who don't know, it's most of the time like a code review. You don't execute your code. Could be manual, could be automatic. Dynamic testing is testing where you do execute your code, and most of the time the logic is tested. And then you have something called gameplay tests. So let me explain that a little bit more carefully. So the virtual reality applications are developed in the Unity engine. And Unity basically provides gameplay testing. And what that is basically functional tests on development level. So functional tests, they can be performed during development. So let me give you an example. Let's say there's a functionality where I have to open the door, I have to press a button, and a rocket will be launched. So that consists of different visual elements, different pieces of code. And the gameplay test allows, basically on development level, to test that all together. So you basically go, you will open the door, you press the button, and the rocket will be launched. So it's, as I said earlier, it's functional test on the development level. And there is a difference of opinion, like does it really belong in the unit test level? According to my understanding and the fact that it's more development focused or developer focused, I placed it in the unit test level. So this is where we focused on the unit test level. Then, after you're done with the unit test, the virtual reality application is loaded into a device. And in the real device testing, we focused on improving the exploratory test, the scripted test, the immersion and accessibility. How did we do that? we basically improved the process, the test process around these test types. Because if your test process, if you have a quality test process, then your testing will also has better quality. And we did that, so why did we focus on the unit test and the real device test? So that the next level, which is the end user test, can be as light as possible. During the end user test, you don't want any major or critical bugs to be found, because that's just not nice. And the end user test is basically the accessibility test, where the product is introduced to the user, they get familiarized with it, and eventually they accept it. So this was the first. So the first thing, as I explained what we did, we turned the pyramid, or the ice cream cone, to a pyramid, and then we looked at the different levels, and it made some improvements in the different test levels. The second thing what we wanted to do was shift left. So we wanted to test early and fail fast. As you can see in this graph, you see that the traditional quality model, or the load of the quality, is late in the process. It's late in the development process. And you also see that the attention to quality also comes late in the process, in the development process. So what we wanted to do was shift the load and the attention earlier in the process. But then we faced some challenges. What were those challenges? So, it's not in the right order, but it doesn't matter. So, first of all, we are dependable of a device. So as I explained, when the unit tests are done, the application is loaded into a device. So when you're in a device, you have to test into a device, so there's a dependency. And the thing with a device is that you cannot test like for very long, because most of the time, the testers, or the person who's testing, cannot test more than 30 minutes, or let's say an hour, because you can experience headaches or motion sickness. So there's basically like a time constraint. You cannot test for very long. And I will go to the last one first. Testing happens too late in the development life cycle. Also, because there's a dependency with the device, you're not able to do extra tests before that. So that means like that the testing comes late in the development life cycle, and you find basically bugs later as we would like to. So if you combine the testers cannot test more than 30 minutes and testing happens too late in the development life cycle, if you combine those two, then the first challenge we had somehow we had to separate our testing from the device. That was the first challenge. Last challenge we had, that's in the middle, was like lack of specialized software for test automation. So at the moment in the market, there are no test automation tools to automate virtual reality applications like you have for websites or web applications. So that means that teams have to come up with their own frameworks. So these were the challenges. And how did we tackle these challenges? Now my friend Joep is going to tell you more about this.
Thank you, Babar, for introducing these great challenges. So this is where we, as Society, came into play. And because of the complexity of these challenges, we thought this was a great fit to implement artificial intelligence. And we did that by proposing a new layer in the pyramid that was introduced by Babar, which focused on AI-driven tests. In this layer, we want to prevent bugs from leaking to the real device test, which means that we want to find bugs that were sipping through from the unit test layer. So we want to catch the bugs earlier than the real device test to prevent testers from having to spend too much time in the real device test. As Babar just said, that can cause headaches and motion sickness. And we wanted to automate this to make it on demand and available to developers while developing or in their release pipeline. And I can hear you thinking, why AI? Why not just regular stuff? Well, AI happens to excel at repetitive tasks, and we discovered that a lot of these real device tests are actually quite repetitive. But at the same time, we didn't want to hard code any behavior. We wanted to still emphasize on the fact that with reinforcement learning, you can really teach an agent, as we called it in this case, to express itself, learn to operate in the environment with minimal controls, so with the same controls that the human has, moving, rotating, pressing the buttons. With these bare minimum controls, we wanted to teach the AI to test in this environment. What did it look like? Well, this is what a single instance of our AI agent looks like. With a set of given tasks, it goes around and explores whether or not it can operate the buttons according to expectation. So it's meant to press a button, rotate a button, etc. And when it does this, when it succeeds, it will outline the button in green, and when it fails, it will outline the button in red. This means that developers can quickly get a glance of what their code is doing. Is it working? Is it according to plan? Are we achieving our happy flows? And at the same time, because we are doing it with an AI, we can record all the behavior that the AI expresses, which can then be used later. So, going back to the pyramid, we have our AI-driven testing layer. We took the repetitive tests from the real device test, the exploratory and scripted tests, and we teach an AI to execute these tasks while recording the execution of these tasks. So whenever we now find a bug, we have the recorded behavior that led to this bug. This recording, this data can then be used to enhance the layer below. Using the data that we gathered in the data-driven tests, we can enhance the tests that we do in the unit testing layer. So now we can write tests for whatever failed behavior tests we saw and catch them even earlier. So now you can develop further, test your code again, and now already in the unit test you can check whether or not you still have the same bugs. What did this lead us with? What was the impact here? Well, we were able to automate functional visual tests, and AI is incredibly fast. So what you saw in the example before, you saw one agent exploring the cockpit, but you can also imagine that during scale-up you can parallelize this and have 100 agents going through the environment at the same time, increasing the speed even more. And developers can now test their code on demand, so they are not required to put on the headset themselves or have an additional tester, but they can just run the code, have it in the pipeline, have it all on automation, and furthermore, we were able to use the recordings, the data, to enhance the unit test. So in the end, we were able to shift left and help resolve some of these challenges that they gave us. I have a short summary here to help you catch up with what we just said. We started with a great challenge from KLM, where they saw that the quality or the quality characteristics of testing in VR are more complex than what people are used to due to the interface and due to the time limitation of people in virtual reality. We came up with a solution introducing a new layer in the pyramid in which we are able to automatically test visual and logical tests and simulate human behavior, of course. And as a result, we are able to use this data to enhance and optimize the real device test and the unit tests. And now we can lower the cost, reduce time to market, and get some happy developers.
Great. Thank you. Thank you very much. Please have a seat. And with us as well right now is Vincent Weinen. He's an automation and feedback consultant at Society. He's got about 14 years of experience within this function, and well, his work takes him to several Society customers. So he helps with all kinds of questions in terms of automation and feedback loops, but he's specifically interested and enthusiastic about virtual reality. So we're really happy that he also joins us. But we already have two absolute experts on the table here, because I was very impressed by your talk, and I just, before I start asking Vincent a question, what impressed him most, I just wanted to ask the people here in the audience, like, who of you is involved in testing virtual or extended reality applications? No one yet. And who's planning on doing this?
They just don't know it yet.
They don't know yet. Okay, so, but I've really seen people watch you closely, so I think that's been good, right? Are you nodding? Did you find it interesting? I have to say yes. Okay, so for the people at home, yes, they're definitely nodding here. And Vincent, what impressed you about this project?
The maturity of the examples. So I've been involved in virtual reality since the dev kit 2, so that's been quite a while. And you quickly saw that the VR was dominated by gaming, which also sometimes relegates it a bit to only for gaming. So I think the VR market has been long overdue with really great examples like these. And I thought, yeah, the things that I saw were really impressive and much further than I had expected them to be. So as a VR enthusiast, I'm really pleased to see that this is gaining so much ground in the professional scene as well.
I see you both smile. This is a really nice project, or not? I see your enthusiasm.
This was, can you still hear me?
Yeah.
Yes.
No, that was a very nice project. It was also a very nice challenge because, as I said at the beginning, we did something completely out of the box. And if you look at the market, there is not much out there to basically use. So we have to be creative and think out of the box. And it was an idea. And we basically executed the idea.
And how long have you been working on this AI testing layer? Like how long did that more or less take before you could start using it?
In this proof of concept, I think we originally had 6 weeks. 6 weeks, 3 sprints.
Not bad.
And what you saw was 6 weeks. It was like the first concept.
Okay.
But you can even enhance it more.
It has way more potential, but we had to scope it.
Because where is this also your current state, or where are you heading towards?
Yeah, so it was basically like we had like a case, and this idea came. So we started with the proof of concept, and the idea was to prove that this idea works, and that we have done that. And so when further developments are going to come, then we have proven that this proof of concept works, so we can really use it when like new developments are going to.
Yeah, so now we're really ready for the next challenge.
Yeah.
Good. You see people laughing here as well. And so how do you think that AI could really be extended in this KLM case?
Well, these tests were, I was talking about the visual and the exploratory test, and in this proof of concept we scoped it down to a lot of predefined tasks. So does this work or does it not work? But AI is much more capable than that. It can also lead to a much more exploratory role where can we really break things? Can we exploit mechanics that we build in this game or in this training simulation that people could use to their advantage in a way that isn't meant to be. If you give an AI 1,000 years, which is nothing for an AI, it can really break these mechanics.
And Vincent, can you tell us something like in general about the use of artificial intelligence in testing?
Well, that's something you've been mostly hearing a lot about, but I haven't been seeing a lot of it yet. And I think one of the things it excels at is making really repetitive stuff much faster to execute. And I mean, as an automation consultant, that's the stuff we've been striving for a long, long time. But what this brings to the table is that you can do it a little more hands-off. So it has some degree of being self-steering. It has some degree of being able to find things out by itself. So if I automate a website, I literally have to use code to tell the computer, like it's a little child, everything it has to do. And here you can basically have it, let it roam free. And of course, there's a lot of nuance involved, because can it decide what's right or wrong? If it turns a knob, does it really know whether or not that's something a pilot would expect? I think there you get into a gray area, but yeah, speeding up repetitive tasks is something we've been doing a lot and striving a lot for, and I have high hopes that this will help us in that respect.
Yeah, and I also, like in your summary, both of you mentioned that this should always be combined with human checks still, right?
Exactly. So 100% automation, I don't really believe in that. I think you can use the automation to basically, like as Vincent said, to make it easier for yourself with repetitive tasks or tasks which are a bit unrealistic for humans to do those. But at the end, the human can focus. Sounds a bit weird, human and the machines, but then the human can focus on other things or more important things, or because the human eye is still the human eye, which can't be replaced. So.
And I think also, replacing has never been part of what it's trying to reach. I think it's very valuable as a different perspective. You know, if you're gathering feedback, the perspective based on, are you doing it from an end user, from a technical perspective, from a functionality perspective, there are many. And I think this provides a really interesting additional perspective. Like you said, you just let it fool around and it might find stuff that you didn't know was possible, but is going to be a big problem when you find it. And I think as an additional perspective, it's more than welcome.
And did that happen already, or can you not say anything about that?
In these 6 weeks, that was something we hoped for, but we didn't achieve. But we know that this is possible. We've definitely seen examples of research where stuff like this happens. But I also want to emphasize on the last point that you really still need the human for its human traits, for its human emotions. How does this feel? How is it immersive? Do I feel like I'm really in the cockpit? You cannot ask that to an AI. It will not give you a useful answer. So
for now.
No, I don't think that will ever.
Okay. And do you see that this? And it's a question to all of you. Doesn't matter who responds to it, but do you think that this AI testing method can be applied also to other virtual reality applications, or even 3D simulations, like what's being used in gaming?
Definitely, and there has been a ton of research to get AI to, for instance, operate games. And what started out with the simple Atari games is already currently involving in much more complex games like Unreal Tournament, Quake, that sort of stuff. And the fact that it's actually quite good at playing these things shows that it's really flexible. The computing power behind it has been increasing steadily over the years as well. So for sure, I think it won't take long before this is usable even in the most modern, complex games.
Yeah, and I noticed that you're really willing to start experimenting. Is this, can any developer just use it, or what do you need to?
Yeah, you need some basic knowledge.
Skills? Yes.
You need some basic knowledge in artificial intelligence. You need to understand what it means, and you need to understand the differences that exist in artificial intelligence. So you have a lot of different models that have different goals and are trained in different ways. So what we used here is really something that observes its behavior and observes its context, and from its observations, it determines whether or not it's taking the right path, for example. So it has minimum input, the controller, just the buttons, just the rotations, and it observes as much as a human what goes around. But there's a lot of different models that are meant for various things. So if you want to be good at this specific thing, I suggest going into reinforcement learning, and then there will be tools that you can use to your advantage.
Good.
Yes, I got to press the button one more time. Very happy. So, question from Jasper. In my experience, VR has been noted as the future for quite a while already now, maybe over 10 to 15 years. But do you think that this will change in the nearby future? And if so, what will or has been the turning point? Who wants to answer that?
So the question is, will VR change the future?
So it has been noted as the future, the future thing to invest in. But do you think that will change? That maybe it becomes part of just our tools and not so special anymore?
I think it already is. I think a lot of things are run by AI models without our knowledge. I mean, if you search something on Google or on YouTube or whatever, you are dealing with models that determine what you are seeing. Yeah. It's in our daily life already, but it's under the hood.
And for VR, something that I've seen quite some projects where companies, for instance, try to use it to display information, but it will never beat an Excel sheet, because 3D stuff flying around you is never going to be as comfortable as to look at as a well-built graph in an Excel sheet. So VR as a technology will always have its niche, and I think it's an awesome addition. I've been a fan for a decade, but I don't think it will replace much more. So where you see AI encroaching on basically all aspects of our life, I think VR will just be a small part of it.
Yeah, I agree.
And I just have a question that relates to this one. If you see, because you're all quite VR specialists as well, what will be like the next development within VR technology, or is this not really happening?
Well,
or
from a Air France KLM perspective, so of course an airline has everything to do with traveling. So we're also trying to, like within Air France KLM, seeing how can we combine virtual reality with really enhancing, not replacing, but like enhancing the travel experience. So we also did a couple of months back like a hackathon together with Society to see can we come up with virtual reality solutions to, let's say replace, but let's say travel. How can we do that? A solution for travel for people like who cannot travel, like maybe people who are not able to because of their age or some other problems. And how can you bring people who are very distant and together? So I think we are looking into that. We're researching that. I think somewhere in the near...
It would really be a service innovation for Air France KLM, right? Because it's really a new...
Yeah, so
it
could be. I'm pretty sure it will, and
yes.
we are just looking into it with the people within Air France KLM. So before you know, you will be traveling with maybe a headset, and
also
lying on your couch.
Answer to the what's it called? Fear flying, right? But not necessarily fear, but also. For sustainability reasons, not wanting to...
Or you will go to an experience center where you just go into a room and everything is there to really make you feel like you're at a beach, you're just wearing your glasses. So that's what I think.
I think that's one of the major things that needs to improve. So the optics really need to become better. The field of view is relatively small, so it's still like you're kind of looking through a few tubes. I mean, our natural vision is much wider. And also the hardware is still relatively bulky. I mean, you can try it in the big hallway in the back, the experience center. You still have a cable hanging on your back. You still need a PC. There are setups where you can carry a PC on your back, but it's heavy. The goggles are heavy. I've used it for hours, and your neck will hurt. Yep. So I think the optics and the hardware will need an extra degree of comfort, because I can't imagine sitting on a flight for 8 hours wearing a headset. It sounds fun, but I'll never make it.
But you've seen like the headsets are getting smaller and smaller, and eventually I think that there will be a size of just regular glasses. Hopefully. And of course, how you deal with the optics and everything, that's a different challenge. Yeah. But I think then it will be more accessible to, let's say, the normal people. But because you're right, like nobody's gonna put that big thing on his.
So I'm curious. You might know Ready Player One, the movie.
Yes.
Is that a realistic scenario? Something we'll be moving into, or the book?
In what time span?
I think it will, but not now, but eventually.
Okay.
I think because you can try it in the experience center. You can walk on a plank wearing goggles, and it's so realistic that you really the reaction of your body is. I'm looking at somebody who experienced that. The experience of your body is real, because your brain cannot distinguish what is real, what's not. So you can really fool your brains and your body. So I think eventually, like when it hits the market more, I think people will try to also find it as like maybe as a relaxation or an escape. So because it gives you that feeling. Not sure if it's going to be like the movie,
But Bar, just to add to that, what has been the experience with, or the impact, so to say, of applying VR at Air France KLM? Because I've seen 3 or 4 applications that you showed in your presentation. So how has it impacted the organization?
Yeah, so what you see is like the trainings that we showed you, like those trainings, so normally, like when you take the fire extinguisher or the fire safety training, normally you have to do it in a room where you have to like lit up a fire and you really have to do the training. Then again, some other group come, you have to do it again. And you basically take that away. So you make certain trainings. Maybe you can't completely replace it, but you can already like pre-train or get people familiarized with the situation, also with the slide raft. Yeah. Like if you're wearing that, it feels and seems pretty real. So it basically helps already in an early stage, I wouldn't say low level, but already get people familiarized with certain elements they have to take care of. And as I said also with the cockpit training, it just makes it easier and more fruitful for, like, let's say the pilot to actually go in a simulator or an aircraft. So we can already see that the benefits of all these trainings. And
yeah. And so if we get back to this AI testing pilot that you've executed, what would be like your desired, your dream, if you know, if you have enough people, if there's enough budget, or
my dream?
Yeah, but yours, but also Joep's, because you've been working together on this, it seems, right?
So yeah, look, my dream would be like, if you look at testing, then most of the time you hear from, this was of course virtual reality, so let's stay at virtual reality, but testing is slow. It takes a lot of time. That's the perception people have, especially managers, that development is fast and testing is slow. It slows us down. So we're looking for like the holy grail to speed up testing as such, but that we don't lose quality.
Yes.
So I think we have proven with this proof of concept that you can bring in that speed, but that you don't really lose that quality because you're dealing with a very intelligent artificial intelligence. And if you talk about the dreams, then I would say like with the dream that we just did one proof of concept and we just focused on one thing, but that you will be much faster with testing with artificial intelligence. Of course, effort is required to set it up, but once that's done, it's more beneficial because you're actually dealing with the intelligent computer intelligence. You're dealing with intelligence than, let's say, a regular test automation tool, which is, I wouldn't say dumb, but it's just like...
It's dumb.
It's dumb.
Okay. Joep, anything to add to that, or?
I think life should be fun. So I want to take away the boring stuff that you have to do when developing, boring tests, repetitive stuff, but still enable the human to enjoy it and have fun with it. So there's fun parts of testing, and yeah, let's keep that for the humans and take away the boring stuff.
So this will make our work much more fun, right? Faster and fun, so more impact
and better.
Get from it, yes. And then, so Vincent, do you know, what do you think that customers, the society, what can they expect? Like, what will you be doing in this field? So what do you think?
I think that AI is going to form part of our toolset because, yeah, what Joep said basically is exactly what I've been claiming automation is trying to do as well. So we use tools to improve a process, take the boring stuff out, and because they didn't hire you with your university degree to just click around. So we try to leave that part to the tool, and I think that toolset will in the future be expanded with AI, which will make us faster, which will make us more flexible. So I hope to be wielding the power of AI in the near future.
And the near future is months, years?
Nah, I think 1 or 2 decades, to be honest.
Good. Let's hope for one then. Thank you. If there are no more questions from Puk and Jeroen or from the chat, then I'd like. Then we've come to an end of the session because it's almost 5.